renewable energy sources. I am working in the Department of Electrical and Electronic Engineering, Recep Tayyip Erdoğan University, Rize, Turkey. And firstly, I want to give some small informations which are maybe Professor Sabir don't say, and we'll start my main topics, my presentation. Yes, we are, my university is here in Turkey, and you are here nearly 22 hours with fly, but not more far, 4,000, nearly 5,000 kilometers from difference between these two universities and two countries. And my university is near the Georgia in Black Sea area, and maybe sometimes you can visit the Georgia or Turkey, another country, and for Batum, for example, and you can come to my university easily. I want to speak firstly about my university and how about some opportunities of the university. This information is for 220 years. Nearly 20,000 students we have, and 1,000 researchers in my university. There was active education programs, laboratories, and classroom research center. The numbers are seen here. Some opportunities of the university is accommodations for students. Education is free flats for researchers, good funds for successful students, incentive for researchers, project support for researchers, project support for students, conference attendance support, 3-month language courses in London for research. Some of my university's opportunities for all of the students and the researchers may be interested. Professor Sabir speak about my CV, so I want to pass this page directly, but you can contact me from this email maybe. I want to speak about a little my journal. We have a journal, and I found it in 2015 years, and we have published it 2 times in a year, and free and open access journal. I am the chief editor. Some of the database we scan it here, shown in the last issue of our journal, seen here. Sorry, sometimes I'm checking the page, maybe because sometimes can be connection problems. So I will sometimes check the page if it will not be a problem. Yes, I have 2 books published in Turkish. One of them is the Electronics Laboratory and includes some multi-sim software explanations, and one of them is Circuit Analysis and Measurement Laboratory. They are published in a good publishing company in Turkey. Yes, after these informations, I want to give the outlines of my presentation. Firstly, I will speak general informations about microgrids. After that, informations about the renewable energy sources, power electronics converters for microgrids. For example, buck-boost converters, bidirectional back-to-back converters. Some of them I will speak about. We can expand them a lot. Control of power converters for microgrids. The main control methods I will speak for example with examples, PID, sliding mode, PLC controls, for example. And I will speak about how to storage energy in a microgrid, in battery as a hydrogen supercapacitor applications, and I will give an overview of my published papers, popular papers, and conclude the presentation and the references I will give. A basic microgrid system is seen here. Maybe some of them don't a lot of information about these matters. Firstly, I want to start in a simple basic shape. The microgrids basically consist of 4 different points. One of them distributed energy sources, energy generation. Maybe it can be a generator, a wind turbine, a solar photovoltaic system. Energy consumption is another part, energy storage is another part, and the connection point to the public microgrid network is another part, the basic microgrid system. If we look at the details of the microgrid system, what is the microgrid power? Firstly, a microgrid would make feasible large community energy projects such as biomass plants, banks, fuel cells, and neighborhood arrays of solar panels or wind turbines. When a blackout occurs, rooftop solar panels often go dead too, since most people have no way to store electricity on site. A microgrid might enable the panels to keep working. And the second point. The third point, conventional electricity is delivered through a tunneled network of substations above and feeders. The third point seen in the figure. The fourth point, microgrids could make a power system more efficient. Nearly 15% of energy preserving here, and less pollution is another point of microgrids useful. The 50th point, for the local microgrid to provide serious backup during a power outage, there would have to be storage, this so-called vehicle-to-grid solution. Maybe this is an important point. I have some studies about this matter, but it will be a different speak workshop matter. It was very large. Yes, what is the advantages of microgrid? What about the microgrids? It is based on the use of high efficiency, low cost, clean energy sources is the first advantages. It provides uninterrupted energy by being safely separated from the regional grid. It meets the instantaneously changing demand needs of the central grid. Losses in power lines are prevented. The risk is distributed. The central grid becomes stronger. After various disaster situations, the problem of line interruption disappears. These are the main advantages of microgrids. The disadvantages of a microgrid is complicated and costly protection circuit design due to bidirectional current, surge and control damping difficulties in AC distribution lines in microgrid in another point. The necessity of establishing a microgrid modeling and control mechanism are the other point. Renewable energy sources are affected by weather conditions is the main problem and disadvantages of the system. Investment and maintenance cost of energy storage unit is the other important point for as a disadvantage. Yes, now I ask to any question as the main question. What is the off-grid and on-grid system? Off-grid, microgrid, on-grid, microgrid. Yes, I want to check again if any problem. And I wonder how many people are now in conference, nearly 50% here. I want to welcome all of you again. I want to say welcome all of you. I hope you will enjoy my presentation. Yes, what is the off-grid and on-grid system? Now I want to speak about this. If you look the figure, we can see the main difference. If you have an off-grid system, you not connect the grid. You can supply your energy from solar panels or generators. It can be an optional, and a battery bank. An on-grid system is connected to grid, and if you need, if you not required energy supplied from solar panels, then you are using the grid. Or if you have a lot of energy in solar panels, you can send it the grid. It is seen here using a utility method. Yes, it is explained here. An off-grid solar energy system is not connected to utility grid, whereas on-grid solar energy system is connected to utility grid. If you look more sophisticated on and off-grid microgrid system, there was a figure which shown a DC microgrid. The first one is operating in a grid connected and off-grid mode, and the other one is an operating a standalone mode. For example, here using some PV sources and some alternating storage storages here from alternating components. There was AC load and AC grid and AC-DC converters, for example, and non-critical loss. But here is using standalone loads, and there's no any connection, but and battery and electric vehicle charge station maybe you use it as a class here as a point. Yes, if we speak about a hybrid off-grid microgrid systems, what is the hybrid off-grid microgrid system? There was two sources here. One of them is wind turbine, one of them is solar panels. They are stored in energy storage systems such as in a battery, and they are connected with a DC bus, and using the AC-DC converter, they are supplied, this source is supplied the house loads in a off-grid microgrid system. Hybrid microgrid system is seen here. Another one is hydrogen cycle and renewable with the microgrid system. What about this? There was a shame which maybe I want to use it in my master thesis. There was wind turbines, photovoltaic sources, batteries, but an alternating using an hydrogen cycle. What is the hydrogen cycle? If you look here, sorry. If you look here, the hydrogen generation is occurred in an electrolyzer. The weather is separated hydrogen and oxygen in a system using an electrolysis, and the hydrogen storage is occurred. For this, used a buck converter, and using a fuel cells, the hydrogen energy converted to electrical energy and supplied the bus and the other loads, which is shown in the right side here. The working principle of fuel cell, alkaline fuel cell. It will be given more detail in energy storage part at the last of this presentation here. It is one of my paper is from International Journal of Hydrogen Energy. You can see in more details about these figures. Yes, I will continue speak about PV sources for microgrids. The working principle of a solar cell is seen here. Using sun, ice, it is possible to generate an electricity in a solar cell. This figure is showing the equivalent circuit model of a solar cell. Combine these solar cells, we can occur a PV module structure. This figure is showing the equivalent circuit model of the module. And we can design these modules in MATLAB Simulink, equivalent models in here for simulations to obtain the IV voltage current curves and voltage power curves to obtain the maximum power point of such a system, such a PV module. It is explained in one of our journal paper is seen here, the details of this design. Because the PV sources and the wind sources is different from the linear sources. It is seen here. When the voltage is changed, the current not changed the same value, same ratio. It is changed because it is an restricted current source, not a undefined sources. Yes. How we can connect the PV sources to microgrid? I want to speak about this. I want to check my connection again. Sometimes in internet problems, maybe it is seen no problem. Yes, there is seen two figures for about PV sources connection. A basic battery, solar energy battery power system is seen here, where is using an indirect method. The PV maximum power point voltage is estimated using the PV characteristic in this method. You are using this characteristic for obtaining the PV model's maximum power point, and the DC bus voltage especially selected as a maximum power point voltage. I'm using this one, this simple one. The other one is the in two systems are using, for example, buck-boost converter to design the output voltage for increase or decrease. There is using the MPPT method, which main is the maximum power point tracking method. In here, we are measuring the current and voltage of the PV source, and using this generated PWM signal, and this signal is switching the converter and obtaining the desired voltage in the output for the maximum power point. It is using some algorithm, for example, perturb absorb one of them. You can check this paper maybe for details. Yes, I will speak here about MPPT algorithms. One of them is the perturb absorb, which is used a lot of using in a lot of studies. This method, perturb absorb. Sometimes it can be using with fuzzy logic and other controllers. There was a simple algorithm, and it is aim to works the system in the maximum power point. For example, left side of the max MPPT, if you are working here, it is try to works here step by step, and if you are here, you are trying to go to the peak values and try to do works the system in maximum power point. Yes, similarly, in the wind sources for microgrids are not nonlinear systems. For example, if you look the basic of the systems, there are some curves for different wind speeds, and wind power is not directly go to the generator. There was some coefficients, for example, turbine coefficients transmission coefficients, generator coefficients, and the total coefficients is from the wind to the generator is seen here. The air value and the cross-section area of the wind turbine blades and the wind speed are using to calculate the generated power from a wind turbine. You can find more details in this link, and we have to do this. We are not using linear sources for a wind turbine. As differently, we are not using DC sources. For example, PV sources is a DC source, but the wind sources is not DC. It is an alternating sources. For this reason, firstly, we have to convert the three-phase AC sources one-phase, single-phase DC DC power, DC voltages. For this, using this converter, and it is not enough. We have to desire the using the DC-DC buck converter or another converter to feed the load. Because, for example, we are trying to storage a battery, we need an 11 voltage or 30 volt voltages, and so we have to increase or decrease these voltages. Or if we are using such a system in second, the first one is off-grid, and the second one an on-grid wind generation system. If we are using this system, there is a converter and another inverter to convert the DC voltage again and AC, maybe three-phase voltages to supply the grid, to send the energy to the grid for an on-grid wind generating system. This figure are from here, and you can check them if you want more details. There was some, for example, there was some different wind turbine applications for in industry or in applications. One of them, for example, three-phase square gauge induction machine at the on-grid system directly can be drive a three-phase AC grid in the system. Maybe another one is double-fed generator for a wind turbine at the on-grid system. There needs some converter, especially for the how can I say, for the introduce both induction generators, rotor or stator windings. It is required such a back-to-back converters, for example. The details of this comparison are given in this paper, one of my paper. Another one is a wind turbine application is permanent magnet generator and using a back-to-back shape directly here. If you look here, the three-phase generated energy is the generator side inverter. Using the generator side inverter, convert to the DC voltages, the energy, and in a DC, on a DC link, and this DC energy converted to an AC using a grid side inverter again to connect the grid. That is using some filters and step-up transformer to reduce the harmonics and to increase the voltages generated for sources. You can check, for example, this paper for more details. There was possible a lot of converters, inverters. It is a back-to-back converter chain, is seen here. And now we are come to hybrid systems. Can I check again my connection maybe? And speakers. There is no problem, Professor Saber. I will continue.
Yes, please continue. You can continue.
Okay. Now, I will speak about hybrid off-grid microgrid systems. Especially in my studies, I focus off-grid microgrid systems, because my aim not give to energy to the grid, especially in mountains, villages, and such a systems. We are using such a systems in my region, in my area, in Black Sea region, especially. The weather is rainy, and not every time we are seeing the sun, and maybe 1 week we are not using sun, and these times maybe the wind is increasing and we can use the wind turbines alternatingly. To be use these two sources at the same times, we proposed such a system. It is my PhD thesis. It was my PhD thesis main topic. How can we combine these two systems? For example, at the same time, we are generating a voltage, variable voltage in PV panels, or we can obtain a variable voltage from the wind turbines. We have to connect them a DC bus, for example, 24 volt. You can to charge the two series batteries, 11 volt. We proposed a DC bus and connecting them such a system using a buck-boost converters. Maybe sometimes the voltage is high, maybe sometimes is voltage low. And we publish them in a paper this year. In this paper, in an electrical power component and system journal. I will speak about papers in the next, the last of this presentation, and you can see in them there. It is the main topics, but we publish a lot of papers about this matter. We are using power electronics converters for microgrids. The title of my speak was in power electronics converters for microgrids. And firstly, I want to speak about the buck converter. The buck converter is decreases the input voltage. The desired voltage level depend on the duty cycle of the switch, and is seen here the switching signal, the voltage, the inductance voltage and current. The inductance voltage and current are the main topics, the main point in the converters. If you try to work correctly the converters, you have to give continuously these currents, and it is required a good value inductance, and for low ripples from the output, you require a suitable condensator, the main parts of this converter. Another one is the power electronic converter is boost converter. It is working similarly. It is seen here when the switch is closed is here, the inductance is current flow here, and the inductance voltage is increased. When the switch is closed, the inductance current continuously supplied the loads, and when you look here, you can see that the voltage and the inductance and source are added, and it's supply to increase the output voltages. Using this converter, it is possible to boost the input voltage from the output. The signals is seen here, more details. Maybe they are from undergraduate course topics, but I want to speak them because sometimes some points maybe some of listeners not take such a courses. Yes, another one is the buck-boost converter circuit, and two states are seen here. When the switch is on, such in here, the current flows from inductance, and when the switching is off, the current continues to flow from the inductance and give an output voltage, reverse output voltage from the output, but you can adjust the output voltage to increase or increase value, which one you want. Sometimes some values I hear, maybe I wonder I check the connection. Yes, this converters is especially used in the previous, such and here is buck-boost converters, from the variables input voltage to stabilize from the output voltage, for example, to supply a battery. And another converter type is bidirectional converter, DC-DC converter circuit. This converter is supply some advantages in such a system. A bidirectional DC-DC converter is a circuit where current flows in two directions, meaning that bidirectional converter can energize the load, and the load side can also send the power back to the source. For example, you are using a battery and you will charge the battery, and after then from battery you will feed the load. You have to use for a bidirectional DC-DC converters from two-way currents, two-way voltages. Yes, I want to give here a back-to-back converter with DC links. The more details are given here. For example, there was a grid. The main usefulity of this back-to-back converter, you can change the frequency and voltages, because you are here a DC link here. You can adjust this side and change. In adjusting this side, you can change the voltage and frequency. For example, in here you are using a wind turbine, and your frequency and voltage is changing, and in grid side converter, for example, and you are using a different load, maybe different frequency load. Firstly, we are changing a DC voltages here, the voltage, and after then, and load side, we are converting an AC voltage, is DC voltage, which frequency we are want, for example, 50 Hz or 60 Hz, but which one we want. These back-to-back converters are using in microgrid systems very a lot. Yes, in the next part, I want to speak about the control of power converters for microgrids. I want to give an example from my paper, one of my paper, again published in the Electrical Power Components and System Journal. Here we compare the three type converters. One of them is a PID controller, but we are using only PI for this converter, proportional integral control, and FLC, fuzzy logic control. I have some studies about fuzzy logic controller, but it is more a large topic, and I don't speak here about this. Maybe if you wonder, you can look my papers. Another one is the sliding mode control is here, and to be control such a system, for example, we are looking to DC bus voltage as seen here, and we using a reference voltage. Comparing these two voltages, we are obtaining an error signal. This error signal are using for a controllers and using comparators, and obtaining their PWM signals. pulse width modulation signal. This signal is drive the converters IGBT or MOSFETs to obtain the DC bus voltage in the desired values. For example, the main topic of the controllers for the converter system is seen here. Because we are using a nonlinear source and nonlinear loss most of times, and so we are using a stable. We try to stabilize the systems. More details you can find about control parts in my published papers. Especially this paper is very favorite, very topic paper, popular paper. It's seen here the details of the PV controllers, PID controllers. For example, the output voltage is seen here. Compare it a reference voltage and obtain it an error signal. The error signal is driven a PI control here, such as seen in this equation. Multiplied some coefficients and obtain it and voltage signal. This signal is compared a sawtooth signal. Especially this signal is gives the switching frequency. The switching frequency defined with this sawtooth signals frequency, and the switching signals drive the DC-DC converter. This shown the block diagram of DC-DC converter with PI controller. We are obtained, for example, yes, we are speaking here. It's seen here the voltage and power of PV sources. There's some, for example, we are using this source. Sometimes give 30 voltages, sometimes give 0 voltages, but especially 24 volt is my maximum power point for this PV source. So I'm trying to stabilize my output voltage is here, is seen here. Is the this line is gives the output voltage. The reference is not seen here, maybe is under this plots. The green one is my PV source. It can be changed, for example, depend on the solar radiation or from with the load voltage can be changed, with the load resistance can be changed. But in two times it can be stabilized in 24 volt with using the PI controller. Maybe there is some ripples on the outside is seen here. The other control method which I am using for microgrids is fuzzy logic control. I will give some small parts is here about the fuzzy logic control. We are using a rule digits in table. It can be changed, but I'm using 25 rules here for error and change error. Is error and change error, and I am using them for fuzzifier rule base and the fuzzifier process in fuzzy inference system, and obtain it here and voltage, and using apply this in a system modeling or the state equations, and obtain it similarly such a output voltage in here. Similarly given two different voltages in input with PV and obtain it 24 voltage for output from the output. It is seen a stable system, but there are some small ripples, maybe again some differences. Another control method is the for microgrids control is sliding mode control. The sliding mode control is especially using for a nonlinear systems. The vectors is come from a nonlinear system trajectory and impulse in a sliding surface and can be stable here. Especially two variables are using such a system. One of them is inductance current, one of them is the output voltage. These two axis gives, one of them is the output voltage, one of them the inductance current. And using a hysteresis control here to restrict the output in a sliding surface is seen here. The simulation result is seen here. It is correctly catch the reference voltage. Maybe there are some ripple, but it can be decreases adjusting the system in some coefficients. But correctly catch the reference voltage is in here. There is another point. For example, here seeing some ripples in the inside part, but there are a lot of small ripples in the PV side. This is sometimes gives some problems in PV sides. In active power control side, it must be investigated different in other research. Yes, especially I used this controller in my studies, and for more details, you can check this paper and other references of my previous studies. Yes, now we are come to how to storage energy in microgrids. Yes, maybe I will check. Do you have any problem from here or? Yes. If not any problem, I will. How is my fast? I will continue more fastly or low. It's okay.
Do you have any question up till now during his first session? Participants, you can even raise your queries later after the completion of the session, or you may even ask at this point of time. What he has explained just now, up till now, that is the power electronic converters in microgrid and different sources.
Yes, maybe there was any question. No.
Yes, there is a question, Mustafa.
Yes, ATAL, good afternoon. How to decide rules for fuzzy logic controller? Yeah, it is a good question. The details of this are given one of my paper in fuzzy logic controller. Now, maybe I will speak a little, but there is no any figure about this part because there was I not give the details of the member how to define the membership functions, especially using the error states and the change of the variation, the error states. The details are given in this paper. I advise this and after then publish it the papers in the electric power components. The state of errors and change of error are using with membership functions to define the rules of fuzzy rules decision table. You can change this table for more rules or less rules. It can be depend of how more correct controller you want to design. Yes, another question. Yes, I will speak the other ones in the next step of my presentation, especially AC-DC rectifiers and AC-DC converters, DC-DC converters. All of them are using in the microgrid systems. I will give some examples in the next step and show their more details. Yes, if not any question, I want to continue the next part. Yes, there is not seen any question. Maybe at the last part, we will have time to answer all of the questions. Yes, the other point is how the storage energy in a microgrid. The main topic is here because the microgrid systems especially supply some useful advantages for the grids to stabilize the grid system and a lot of usefulness here. I will speak about the battery-based storage system is here, the basic and simple part of the systems. The supercapacitors for energy storage, I have now focused some studies about this. Hybrid energy storage systems and proposed hybrid energy storage system with supercapacitors. Storage the energy as a hydrogen and other proposed PV hydrogen system and other novel storage system, the main topics I will speak about here. Firstly, the battery-based storage in an off-grid system is seen here. There is no using a grid connection in such a system. Firstly, the PV and PV area and wind turbine energy is converted at DC and using a charge controller system charged a battery and maybe this is a bidirectional converter can be, and when you need this energy you can use it for DC loads, dump loads, and from AC loads you have to convert it with using an inverter. We have to invert the energy for AC loads. Such a battery-based storage system. This is a hybrid system, maybe called. For an on-grid system, this is an on-grid system, on-grid battery-based system. You are using, we have to do, for example, here some connections to the grid and from grid to the microgrid for energy transfer in two sides is seen here. You are required AC/DC converters and rectifier using from IGBT to convert AC/DC conversion. You are need an energy storage and you have to feed the loads and the system in two way. And a PV source, renewable sources with a DC-DC converter, you have to supply the battery and DC loads here. This is the battery-based on-grid system which is connected and system, a grid. Yes, there is a problem. The batteries is not used every time an efficient solution. There was a lot of problems about batteries, their life, energy efficiency, power density, energy density are the main problems. So in last years, proposed the supercapacitors for an alternating way to storage the energy. Especially they are using together in such a system to increase the efficiency of the storage. The main structure is given here for supercapacitor. They are using electrical double layers different from the normal capacitors and activated carbon in two sides as separators here, and they are using they can be high capacity. For example, 100 farads can be possible now, but their voltages is especially low. inner standards is 2.7 voltage is especially using in seen here. For example, in Maxwell is the most known capacitor producer in Turkey, in world, in market. We are studying on this. You can find some studies of my about supercapacitors. And hybrid, we look the hybrid energy storage system is here. If you look the battery or supercapacitor together, it is called hybrid energy storage systems. You are using the PV source, using a charge controller, supply a DC bus, and the energy can be stored in a battery or supercapacitor. If we using, they are using a bidirectional DC-DC converter especially, and you can control them with different methods, passive, semi-active, or active hybrid energy system, depend on the controllers. Maybe some of them not controlled, they are called passive hybrid energy system. Some of them controlled, they are called semi-active. Some of them full controlled, they are called active hybrid energy storage systems. One of my popular paper is given here, published with Professor Blebjak from Denmark when I was in Aalborg University for my postgraduate, postdoctoral research. I proposed here a different approach and a new topology with hybrid energy storage system. I want to speak about here. We are using a PV module and MPPT controller for PI controller for increase the converter efficiency and to work the maximum power point from the converter to use the battery to PV voltages. But I propose here to share the energy from the supercapacitors and the battery. The main problem is maybe here. When the battery stores the energy, when the supercapacitor module will store the energy. I use it as here in a simple method. For example, for peaks values are saved in a system, and this peak values energy quickly, instantaneously charge it in a supercapacitor modules, and maybe then charge it those batteries in here. The aim is this system is for partial cloudy days easily quickly charge the batteries. Firstly, you are charging the peak value as a supercapacitor module. After that, you are charging it in a battery. Yes, the details are given here. The DC output of the converter connected with a supercapacitor module and the battery module with two switches is given here, two switches. These switches are using to activate the supercapacitor or battery to supply from PV module. These switches are driven by a signal obtained from the comparison of PV input voltage with a peak shaving reference. Yes, we are using here a reference, peak shaving reference, to curtail up to the reference levels and storage them in a supercapacitor module. Yes, this was one of my study, and we are continuing this. The other alternating is the storage the energy as a hydrogen. Again, I have a paper and I copied this figure from there. There was a lot of scenarios today in scientists, in manufacturers, in companies. They are using maybe, for example, in houses, how to storage the hydrogen, or in cars, how to use the hydrogen. Mainly, they are similar systems, For example, if you look the first scenario, the photovoltaic sources are using a DC-DC buck converter, coming and electrolyzer, and a water input and oxygen output here. And hydrogen is stored to underground. And after that, because it can be dangerous and easily flows, easily go out, to be storage, to storage the hydrogen is the main topic in here. And using the fuel cells, we again convert to the energy from electrical energy, and using a boost converter, VR and DC inverters, we can supply the DC loads and AC loads here. Is the first scenario. The second scenario is using them in a electrical cars. For this, for example, a photovoltaic array are using on the top of a car or bus, and DC-DC converter are converted the energy in the electrolyzer with an electrolyzer and storage in a hydrogen, and converted again when you need in a fuel cell. For example, you can wait in a park and you can storage the energy as a hydrogen, and when you need, you can convert it with a fuel cell in electrical energy, and using a boost converter, you can drive a BLDC machine and you can use your car, for example. This is one of my papers, and I developed it another paper. It is a very popular paper for this very popular chapter, and I think I have a lot of experience about this matter, so I want to speak about this a lot. For example, the details of the previous part are given here, but we are using an MPPT controller here to be maximize the efficiency in the PV side. This converter decrease the voltage and using it for electrolyzer and store the energy as a hydrogen. After that, we can use it a fuel cell and obtain it a DC voltage again. With a boost converter, we are increasing it for drive an electrical vehicle or DC loads, inverter, AC loads, and others. This figure are combination of these two scenarios. The combination of these two scenarios are given here to summarize. Similar methods are using, but we are using differently, more detailed, an MPPT controller here. Yes, there was a question maybe. I will check again. No, any question. Sometimes I am hearing some noises. Yes. Now I want to speak about converters and MPPT control. The details of the proposed photovoltaic electrolyzer converter system is given here. Maybe we are not using only this part. We are using this part here. I'm working on this part to generate hydrogen with electrolyzer. I'm using the electrolyzer load. The PV voltage is coming here, and the voltage and current inside are measured and applied an MPPT and perturb absorb method, and obtained voltage are using a PI control, switching the MOSFETs or IGBT for a buck converter in here, and obtain the desired voltage level to drive an electrolyzer to make an electrolyzer process. The details are given in this paper. It was only a simulation study. Previously, some of them I was maybe with laboratory, but it is not yet. I need some students to be try on it, and experimentally, for experimental study, I need some projects and students to study on. Yes, this table is give my simulation results to efficiency comparison table for different solar irradiation and temperature levels for this design. It is seen here for different temperatures and different solar irradiation coming a PV array. How the efficiency are changing, for example. If you look the table, the red words are seen the most efficiently results. There is seen the 90% is seen in this result. For example, when the solar irradiation is nearly 900% or 1000% watts per meter square for different temperatures. Especially is seen here for middle temperatures are more good, but when solar irradiation is low, they obtain the best results here in the 75 centigrade degree for such system. This is give the efficiency of the converter, because this one is the temperatures, the efficiency is seen better in these results. This gives the graphics of the efficiency comparison with solar radiation, and in here is seen for efficiency. Maybe I see again any question? No, there is no any question. Okay. After this hydrogen production process with converters, I want to speak some other novel storage system for microgrids, maybe some other researchers. There is using, for example, wind turbines, energy storage, and biomass energy in micro turbine generated biomass energy, and using a DC-AC converter rectifier maybe supplied the DC bus, and maybe it is connected a grid. It is seen here, DC-AC, and DC loads, for example, in lamination. There is using two hybrid energy storage system, the battery and supercapacitor, for example, in this SCET. The wind turbine, it is depend only a wind turbine and biomass. Two sources are using. There is no using a PV sources, for example. In AC sources convert to DC and using the storage energy in DC side, and using for DC loads and to create or another loss. It is another novel study are given in literature. Another study is given here, a schematic grid connection microgrid with various distributed energy resources. Here it is connected an electric grid seen here. There is required a microgrid central controller. Maybe it is very important for microgrid system. There is need a lot of studies using PV sources here in this study, PV sources, battery storage, and there's using a fuel cell stack and waste to generate electricity, or natural gas are using. You can combine in a microgrid system, such a system, a lot of sources, and you can supply a DC link and AC electric grids. It is possible for such a systems. Another study is given here, a typical DC microgrid, and differently, you can see here an electrical vehicle charge station. Maybe it is very popular today because it will be more disappear. Electric vehicle charge stations, how to affect the grid. I was speak a conference a few days ago, and there was saying the electrical vehicle charge stations will be affect more to grids, and we will need more renewables to stabilize the grid to not to affect from the electrical vehicle charge station, because especially for fast charge station you are needs a lot of currents, and there's another hydrogen cycle here, maybe for fuel cells, and microgrid generation system here. This seeing the DC-DC, AC-DC converter, rectifiers, and inverters, all of them are required such a system. It will be published in another paper. Maybe we can see that. Yes, now I will speak some other novel stories. Yes, sorry, excuse me. An overview on our published popular papers about these matters. For example, these two papers published in hydrogen energy. One of them is 2020. One of them is 2014. One of them was my master thesis, and one of them is my postgraduate studies in Aalborg University. Maybe I studied on it. And the main topics are hydrogen generation, PV electrolysis, and synchronized converter is other matter. Synchronized converter, maybe I don't give so details in this chapter, but maybe I will return to seeing you this. For example, you are using here a recovery diode. Instead of this, you are using a switching MOSFET. Maybe it will be increase the efficiency more. I will try. I don't try, but it can be a research matter. Maybe how to increase the efficiency. It is very important, for example, because the losses of the MOSFETs are less than the diodes. For this reason, especially using the synchronized converter. In here we are using this. Yes, another one, again, physiologic controller. The parallel connection, parallel converters are maybe used for high energy transfer, especially. It is another important point. Using in this paper, synchronized back DC-DC converter, again for water electrolysis parallel convergence. One of this paper is one. The other one is an efficiency solar hydrogen DC-DC buck converter with sliding mode controller in another study about this topic. Maybe you can find more conference papers and other studies in my scholars. Another two papers published in the electrical power components and systems. They are my PhD related my PhD thesis. One of them is they are from PV hybrid system, buck-boost converter and control. One of them is compare different controllers for stability analysis for photovoltaic powered buck-boost DC converter. The other one is the parallel connected buck-boost converter with fuzzy logic controller for hybrid energy system. It was published this year. Yes, Another paper is hybrid energy storage and supercapacitor and PV system. It was I given previously a hybrid PV battery supercapacitor system. It is published in the electronics in MediaPi with Professor Frede. And the other one is another important matter is the modeling of supercapacitors based on a simplified equivalent circuit. Because the simulations we are using our supercapacitors models, it is not yet found in the MATLAB Simulink toolbox and library. Some of them, maybe it is not useful for us. This was selected the popular paper in this journal last month. Yes, you can find more papers and studies can be in my Google Scholar and ResearchGate pages about my studies, more details. Maybe some of them publish it in Turkish, but they have English abstracts and maybe some figures. Yes, I want to speak about, I will answer the questions, but after my presentation, I will a few slides to complete the time. I'm using the time more efficiently, I think. I finished 2 master theses for foreign students. One of them was from India and one of them from Djibouti. The thesis titles are given here. One of them is transformers photovoltaic system, FET single phase induction motor drivers for water pumping. One of them is design and implementation of single input multiple output DC-DC converter for solar energy applications. They are published in English and you can find them in internet. Yes, these students are use some funds in my country. Republic of Turkey Ministry of Culture and Tourism Presidency for Turkish abroad and related communities are give some scholars, the abroad students in our country. For example, I advise us to check for Turkey scholarships in this page. www.itp.co.tr English or Turkish page. A lot of students are coming in Turkey and using these scholarships. They are made their master and PhD studies easily. And our country gives such a good funds for students now. Thanks you for patiently listening to me. Also, I would like to thank Professor Sabir for inviting me to these events. We are together in Aalborg University 2 years ago for postdoctoral research at the same time, and we will continue our collaborations. I hope it will be continue in the future. Yes, any questions about presentation? I will maybe a little quick. We have time, no problem. I finish maybe a little quick.
Yes, any question from participants? If you have any question, then please raise your queries. Meanwhile, I'd like to ask a couple of questions, Mustafa. Could you just go to the slide number 29?
Sorry, again, please. I don't hear.
Could you show me the slide number 29?
29, yes.
Yes. So meanwhile, other participants fetch, recall,
Yes.
and ask question. Let me ask. Yes. So in this, as you suggested, it is a combination of the PI plus FLC plus FLC plus SMC control. That is the proportional integrator, fuzzy logic, and sliding mode control.
Yes.
in that you said that is a non-linear kind of the load. So especially which kind of the load that you have considered in this particular case?
Yes. Firstly, I want to say that they are not using combinations. I tried them separately.
Okay. Okay.
Only the figure showed this. I used the battery loads and DC loads especially. I tried the state of charge for different battery loads. I using as a nonlinear load the batteries, and I tried different state of charge of the battery.
Okay.
Maybe.
So there won't be any special kind of the DC loads that you have considered?
No, I maybe one of them I tried the electrolyzer loads as a different loads, DC loads, but not tried the DC loads. Maybe the DC machines can be, BLDC machines can be tried in a different study, but I don't try it. Maybe our students in their thesis make such a study.
Okay. Then on the next slide.
Yes. This one?
Yes, in this one, as you said that the voltage is changing, PV voltage is changing from say 15 volt to around 30 volt, and your output voltage is trying to remain constant, which is around 24 volt or something like that.
Yes.
So I couldn't figure out why that PV voltage is changing. Because as we change the insolation, as we change the irradiation, the PV voltage, the PV output voltage won't change in a wider range.
Yes, thank you for question. Maybe I go too quickly to finish the time, finish on time. If you look the curve of PV curves, if you are obtained 30 voltage here, there is no any loads. There is no any load. You can obtain 30 voltages here.
Yes.
If you are increase the loads, then the voltages decreases.
Yes.
I was give it in the previous slides in IV curves. So in this curve can be obtained in the simulations. I have some studies for designed PV models. Maybe you can look this one. It is depend on the changing the load maybe, but at the same time it can be changed with the solar irradiation. If you change the solar irradiation, it can be changed again. Maybe I can open if we have time, I can open this paper and can show the details of this. Maybe the heat can change the shape of the curve.
Okay, so here you are not going to extract the maximum power. You are having you are just trying to get the control voltage, or the MPP is also incorporated?
No, there is no. We accept the 24 voltage is our maximum power point of the PV source. In here we can say speak about an indirect method. Indirect method is used in the literature without an MPPT control. You are accept that my output is 24 volt for the maximum power point, and I have to adjust it here. It is an easy and practical solution. Maybe not more efficiently, but it is an easy and practical solution. For this reason, I tried this.
Oh, okay, okay.
I hope it is understand. Maybe.
Yes. Could you next to slide number 37?
Okay. 37.
Yes, 37.
Yes.
Yes, this one. So here it is very interesting that it is a blend of supercapacitor module and a battery. But how do you select the size of the capacitor and the size of the battery. So is there any relationship between choosing the capacity of supercapacitor and the battery, or on what, I mean, what criteria that we should
Yes.
consider while selecting the sizing of battery and supercapacitor?
Good question. I was given here, maybe one of the capacitors is give 2.57 voltage, maximum voltage.
Yes, yes.
So we are using supercapacitor modules. We are connecting the supercapacitors serially or parallel. For example, one of my other paper published in next month is about this, how to design a supercapacitor modules. Maybe you can look in my scholar. We are adjusted the supercapacitor modules maximum voltage, the battery voltage. For example, 12 volt is from the battery, and supercapacitors maximum voltage. You can use, for example, 5 capacitors serially and obtain it 12 volt storage voltage. And if you want to increase the current, then you have to connect the batteries parallel, and you can increase the supercapacitors storage energy. But there is another problem. For example, if you increase the capacitor serially, then their capacitance is decreased. Maybe there was some details to be. I advise is to look these papers maybe for more details.
Yeah, sure. And the MPPT is also running in background in this case.
Yes, it is working. It is combined with the PV voltage, PV solar modules together, and MPPT works here.
Okay.
So this is using for this site, and these two switches are another. There's another algorithm. This site is another algorithm for the M. This M is using MPPT. This is a boost site, and these other switching sites, they are using only for switching to share the energy.
Okay, and suppose if the battery is fully charged, the supercapacitor module is also fully charged. I mean, it cannot accept more amount of the energy, neither battery nor supercapacitor. Then what would happen in that case?
Yes, this paper only give the basic of the study. More details, it will be published in the next papers.
Okay.
They are under review now, waiting 1 year, 2 years. There are a lot of control methods to sharing because it is very complex. You have to adjust the battery and super. They are using maybe there is no scene. We are using the next step bidirectional converters for the next step in here. Here using only boost. I will show them in the next paper, I hope.
Yeah, sure. Any other question from participants?
There was any I seen, I think, writing on the chat. Maybe I can read. Good afternoon to one and all from Northeastern Regional Institute of Science and Technology. Thank you for such a beautiful presentation.
Yes, I also should appreciate it. Was a very nice presentation, Mustafa.
Yes, it was maybe my first experience for such a workshop. I hope you enjoy. I'm very happy to enjoy my presentation. I try to combine all of my studies in this area. I try to step by step, maybe simply I started, maybe some different areas.
Yes, definitely. So if there is no question, then I would like to wind it up. If there are any question from the participants, even later on you can have the question, you can send us to us and I'll divert that question to Dr. Mustafa. Dr. Mustafa, it's indeed a very good presentation, and it was just bundle which consists everything from basics of the microgrid, AC/DC microgrid, to the storage system and the various power electronic converters, power electronic devices incorporated in order to improve the efficiency, in order to have the better interface and make the system more effective. I mean, so it was a very nice presentation. You have tried to incorporate everything from PV, wind, even electrolysis and battery structure, everything. So I'm very much thankful. It was a very nice presentation, and I hope everybody, every participant, all participants must have enjoyed your presentation. And I'm also very much thankful that you have spanned time from your busy schedule. I know that you are a very busy person. You have a lot of stuff to be carried out. But even though you have accepted our invitation and spent at least 2 hours for such a faculty development training program, so I'm very much thankful, Mustafa. Thank you very much.
And thanks to give me such a invitation, and I hope it is very useful for you. I'm very nice, and we will we will continue our collaborations.
Yeah, sure.
You can contact me every time with emails.
Yeah, we used to talk, we used to message oftenly, so definitely
Yes.
we'll be in touch with you.
We are waiting you maybe in our city, country.
Oh.
Maybe in the next years we will be organize
Sure.
a conference. I hope to hear you.
Sure, Mustafa. Okay, thank you very much.
See you. See you.
See you. Thank you.
Sir.
Yes, bolo.
Now students are requested to give the feedback. The link is given in the chat box for session 3. Participants are requested to give the feedback, and the link is shared in the chat box.
Kindly attempt the feedback and then leave the meeting.
Okay. If you share me, I will be happy the same.